Yeah. Be rolling through the numbers, counting every step. Equations in the air like a beat, now we prep. Sebastian on the track, yeah, he knows the grind. Mathematics in his mind, no limits, just unwind. Digits dance around, so precise, so clean. In the world of math, he reigns supreme. We're taking over with the power of numbers. Sebastian Simon, yeah, he's got that thunder. Confidence is key, watch us break these walls. In the math game, we stand, we won't fall. Hey. From algebra to cow, watch him break it down. Grab some theories here, wearing knowledge like a crown. Sebastian's on a mission, ain't no problem too tough. In this math game, he's the one who's got the stuff. Riding high on numbers, feel the vibe ignite. With every calculation, shining so bright. We're taking over with the power of numbers. Sebastian Simon, yeah, he's got that thunder. Confidence is key, watch us break these walls. In the math game, we stand, we won't fall. So when you hear the beat, remember the name. Sebastian Simon, destined for fame. So when you hear the beat, remember the name. Sebastian Simon, destined for fame. Hey.
Welcome to class. So, today we're learning about systems of equations using elimination. Okay. So, we're going to be adding these two. Okay. So you're going to learn about multiplying a couple of equations, adding them, finding x and y, finding them in ordered pairs, and so much more. So we're going to add, okay, so we have 2x plus 3y equals 8. Up at the bottom, we have 5x minus 3y equals negative 1. On the second equation, on the second system, we have 2x plus 5y equals 19. And then on the bottom, we have x minus 2y equals negative 4. So we're going to eliminate one of those two. So, to do this, we're going to add the equations. And we have 7x equals 7. Then we're going to divide it by 7. And then we get x equals 1. We're not done yet. So now we're going to replace x okay. So we're going to use the second equation. 5x minus 3y equals negative 1. X is 1, so we have 5 minus 3y equals negative 1. So, this might be tricky. So 5 is 5 times 1. So x is 1. So we're gonna okay. So we're gonna be subtracting 2 from this second equation, I think. Okay. Okay, so yeah, my notes said that we're doing it to a first equation, not that. So 2x plus 3y equals 8. So we're gonna simplify 2, 1 plus 3y equals 8. We have 2 plus 3y equals 8. We're gonna subtract 2 from both sides. We have 3y equals 6. Divide by 3, and we're going to get y equals 2. So our ordered pair for this, x is 1, so 1, y equals 2. This ordered pair will be our answer. You don't have to do that. You're good, right? X equals 1, y equals 2. But you have to box where your answer is going to be. So, for this one, if we subtract 2x minus x, we have x. And if we subtract 5y and 2y, we got 3y. So, we're going to find something to cancel out one of those two. Okay, so we're going to multiply the second equation by -2. So we're going to multiply all of this by -2. Wait, now we have -2x plus 4y equals 8. And now I'm going to erase this, and we're going to be all fine with -2x plus 4y equals 8. Okay, so this is what we now have. We're gonna so we're gonna add these two. 2x plus -2x. Well, 2 minus 2 is 0. So we're going to write it out as 0x. 5 plus 4 is 9. 19 plus 8 is 27. We don't have to worry about the 0x because 0x is not part of our equation anymore. So what we're going to be doing is that we're going to divide by positive 9. Now I have y equals 3. Since y equals 3, we're not done. So okay, so we're going to be testing the first equation. And if not, then we're going to test the second equation. So let's try 2x plus 5y. 5 times 3 equals 19. So we have 5 times 3 is 15. 15 equals 19 plus 2x. Minus 15 on both sides. And we get 2x equals 4. 2x equals 4. My bad. I was about to write 14. Sorry if I messed you up there. Divide that by 2. X equals 2. Okay. So here's our ordered pair. 2, 3. Okay, So if I'm missing something, let me know. But we're gonna move on. We're gonna move on to the video. Okay, so this video was talking to us about systems of linear equations by elimination. So the video is nearly 60 minutes long. So
using the elimination method, we will cover a range of examples, including systems of equations involving fractions, as well as those with infinitely many solutions or no solution. To solve a system of equations with the elimination method, we will add the equations together to eliminate one variable with opposite coefficients. In this example, the y variable has opposite coefficients. In the first equation, its coefficient is positive 3. In the second equation, it is negative 3. When we add these two equations, y will be eliminated because 3y plus negative 3y equals 0. That's why it's called the elimination method. Now, let's add the other terms. 5x plus 2x equals 7x, and 12 plus 9 equals 21. Then, divide both sides of the equation by 7 to isolate x. Cancel out these, and 20 is equal to 3. Now that we have the value of x, the next step is to find the value of y. We can do this by substituting x with 3 into one of the original equations. Let's substitute it into the first equation. 5 times 3 is 15. Then, subtract 15 from both sides of the equation. These cancel out, and 12 minus 15 equals negative 3. Then, divide both sides by 3 to isolate y, and you get y equals negative 1. Finally, write your solution.
okay. So yeah, we will substitute the 3 for x. So yeah, so we have 5x plus 3y equals 12 plus 2x minus 3y equals 9. So we add those up. Now we have 7x equals 21. When we divide it by 7, we get x equals 3. Over here, we have 5x plus 3y equals 12. So he substituted 3 for y. X. So 15 plus 3y equals 12. So now he subtracts 15. Now we have 3y equals negative 3 divided by 3 equals negative 1. I'll give you a moment to write them down. Okay, let's go on.
As an ordered pair, 3, negative 1, with x equal to 3 and y equal to negative 1. If you were to plot the graphs of these two equations, the lines would intersect at a point 3, negative 1. We can confirm that this ordered pair is a solution to the system by substituting it into both original equations. Substitute 3 for x and negative 1 for y.
Yeah, you could check if you want.
15. 3 times negative 1 is negative 3, and 15 minus 3 is 12. In the second equation, 2 times 3 is 6. Negative 3 times negative 1 is positive 3, and 6 plus 3 is 9. As you can see, both equations are satisfied. confirming that the ordered pair 3, negative 1 is indeed the solution to the system of equations. In this example, the coefficients of the y variable in the two equations were opposites and immediately cancelled out when added. But what if you don't see a variable that can be eliminated right away when you add the equations? In this example, adding the two equations will not eliminate either the x or y variable. So, what can you do in such a situation? We can multiply the first equation by a constant to make the coefficients of either variable opposites. But before that, we need to decide which variable to eliminate, either x or y. Let's eliminate the x variable. Since the coefficient of x in the second equation is positive 3, we want the coefficient of x in the first equation to be negative 3, so that they cancel out when we add them. To do this, multiply the first equation by 3. Note that as long as you multiply both sides of an equation by the same number, the equation's equality remains unchanged. 3 times negative x is negative 3x. 3 multiplied by 2y is 6y. And 3 times 5 is 15. Now the coefficients of the x terms are opposites. If we had chosen to eliminate y, we could make the coefficients of y opposites by multiplying the first equation by 2.
Okay. So you realize what he did there. So he multiplied the first the first equation. So negative x plus 2y equals 5. He multiplied that by 3. So now he has negative 3x plus 6y equals 15. So how did he do that? So he used the distributive property, or double rainbows. Yeah, double rainbow. Triple rainbow. Because 3 times negative x, and then 3 times 2y, and then 3 times 5. You all know what 3 times 5 is. It's 15.
This would result in 4y in the first equation, which will cancel out with a negative 4y in the second equation when you add them. Regardless of which variable you initially choose to eliminate, you will obtain the same answer in the end. The next step is to add these two equations. These cancel out. 6y plus negative 4y is 2y. 15 minus 23 equals negative 8. To isolate y, divide both sides of the equation by 2, and you get y equal to negative 4. The next step is to find the value of x by substituting this value of y into one of the original equations. Let's substitute it into the first equation. 2 times negative 4 is negative 8. Then add 8 to both sides of the equation. Cancel out these. 5 plus 8 equals 13. If you multiply both sides by negative 1, you get x equals negative 13. Therefore, the solution to this system of equations as a coordinate pair is negative 13 comma negative 4.
Okay, so he got negative 3x plus xy equals 15 plus 3x minus 4y equals negative 23. So he added those equations up, and now he got 2y equals negative 8 divided by 2, negative y equals negative 4. He substituted that for y. So negative x plus 2y equals 5. And he multiplied 2 by negative 4. So now he got negative x minus 8 equals 5. He added 8 to both sides of the equation, like you should do. Negative x equals 13. Well, we don't do negative x. Instead, we multiply that by negative 1, if that ever happens. Now he has x equals negative 13. The ordered pairs are negative 13, negative 4. In our next video, graphing systems of linear equations by graphing, you'll know how to put things in slope-intercept form and learn how to do a system of linear equations by solving. But you need to do like this, but you need to solve. Yeah. Yeah.
In this example, we were able to make the coefficients of one of the variables to be opposites by multiplying only one of the equations by a constant. However, in the next example, it doesn't appear that we can make...
Yeah, we're only going to be doing half of the video today.
Multiplying just one of the equations. This is because there is no integer by which you can multiply 11 to get negative 7, or by which you can multiply 7 to get negative 11. Since 11 and 7 are not multiples of each other, the same goes for 8 and 6. So instead, we need to multiply both equations by different constants.
He has a point. So, I'll give you a minute to think about that. Okay, take a look at these multiples. So, you see that 7 has its multiples. 7, 14, 21, 28, 35, 45, and 49. And 42, and 49. 11 has its own multiples, which is 11, 22, 43, 44, 55, 66, and 77. Yeah. Yeah, so the top numbers are the multiples of 7. And the bottom are the multiples of 11. So 7 and 11 aren't multiples to each other. Okay, so look at the multiples of 6 and 8. The top numbers are the multiples of 6. The bottom numbers are the multiples of 8. So, the multiples of 6 are 6, 12, 18, 24, 30, 36, 42. And the multiples of 8 are 8, 16, 24, 32, 40, 40, and 56. Let's get back to the video.
Let's decide which variable to eliminate. Let's eliminate the one variable. Because the least common multiple of 6 is 24, we can make the coefficients of y opposites by multiplying the first equation by 3 and the second equation by negative 4. This way, we will have 24y in the first equation and negative 24y in the second equation. And when we add them, they will cancel each other out. So, let's do that. 3 multiplied by 11x is 33x. 3 multiplied by 8y is 24y. And 3 times negative 6 is negative 18. For the second equation, negative 4 times 7x is negative 28x. Negative 4 times 6y is negative 24y. And negative 4 times negative 2 is positive 8. Now that the coefficients of the y terms are opposites, the next step is to add these two equations. Cancel out these. 33x plus negative 28x is 5x. Negative 18 plus 8 is negative 10. Now, if you divide both sides of the equation by 5, you get x equals negative 2. Next, calculate the value of y by substituting this value of x into one of the original equations. Let's use the second equation. Replace x with negative 2. 7 times negative 2 is negative 14. Then, add 14 to both sides of the equation. On the left side, these cancel out, leaving us with 6y. On the right side, negative 2 plus 14 equals 12. Now, isolate y by dividing both sides by 6. So, y equals 2. As an ordered pair, you can write the solution as negative 2, 2. In this example...
Okay, so this will be our last video that we're going to be doing today. So, last example that we're doing today. So, the equations are 11x plus 8y equals negative 6. And the bottom equation is 7x plus 6y equals negative 2. So, he did 33x plus 24y equals negative 18. He subtracted, he added 28x minus 24y equals 8. So, now he had 5x equals negative 10. He divided by 5, he'll get x equals negative 2. He substituted that for the second equation of x. So, negative 7x plus 6y equals negative 2. He multiplied by negative 2, in parentheses, by 7. Now he has negative 14 plus 6y equals negative 2. He added 14, he got 6y equals 12. Divided by 6, he got y equals negative 2. He used triple rainbows again for both of these. Okay. Thanks for watching this video. Hopefully you're inspired from the 3 examples that we did together. And as always, like and subscribe.